Human beings, from our earliest beginnings, have searched for solutions to basic problems. Building homes, measuring space, keeping track of seasons, and counting objects. Over 30,000 years ago, early Paleolithic people kept track of the passing seasons and the changes of weather for planting. To represent the passing of time, they carved tally marks on cave walls or slashed tallies on bones, wood, or stone. Each tally stood for one. But this system was awkward when it came to large amounts, so symbols were eventually created that stood for groups of objects. Sumerian clay stones have been found that date to the 4th millennium BC. A small clay cone was used for 1, a clay ball was used for 10, and a large cone stood for 60. Written records from around 3300 BC show that Babylonians inscribed amounts on clay tablets with a reed. They used a nail shape for 1s and a V on its side for 10s, combining these symbols to write other numbers. For example, Babylonians wrote the number 19 as. The ancient Egyptians used objects from their everyday life as symbols. A rod stood for 1, a cattle hobble was 10, a coiled rope was 100, a lotus flower was 1,000, and so on. The number 19 was a cattle hobble and 9 rods. The early Romans created a number system that we still see today. Along with other symbols, they used an X for 10 and an I for 1. By the Middle Ages, Romans were putting the I to the right of the X for 11 and to the left for 9. So they wrote 19 as XIX. All these creative number systems show groups of objects as well as individual objects. Some of the oldest human counting systems rely on fingers and toes. So they were based on 1s, 5s, 10s, and 20s. The Zulu word for 6 means to take the thumb of the right hand, meaning that all the fingers on the left hand had been added up and the other thumb was needed. Other systems evolved from commerce. The Yoruba in Nigeria used cowrie shells as currency and developed an amazingly complex number system. It was based on 20s and on the operations of multiplication, subtraction, and addition. For example, they thought of 45 as 3 times 20 minus 10 minus 5. Knots tied in cords and strings were used for recording amounts by many cultures, like the Persians. The Incans used a more refined version called a quipu, a thick cord held horizontally from which hung knotted string. The kind of knot the Incans used, along with the length and color of the cord, represented 1s, 10s, and 100s. In today's world, almost every industrial culture uses the numerals 0 through 9. But these symbols weren't invented until the 3rd century BC in India, and it took another 800 years for the idea of 0 with place value to be constructed. This big idea dramatically changed the face of mathematics. We humans have always shared with one another. When early cultures shared their food and water or wanted to divide their land in ways that were fair and equal, fractions gradually emerged as symbols for these fair share situations. The ancient Egyptians used unit fractions. Fractions where the numerator is 1, like 1/2, 1/3, and 1/5, and would add and halve these fractions. If they wanted to divide 3 loaves of bread equally among 5 family members, they'd first divide the first and second loaves into thirds. Then they'd divide the third loaf into fifths. Finally, they'd take the remaining 1/3 from the second loaf and divide that into 5 pieces. They wrote this as 1/3, 1/5, 1/15. Today, we would represent this sharing with the fraction 3/5, 3/5 of a loaf for each person, or 3 loaves divided by 5 people. The Sumerians and early Babylonians invented a number system of fractions based on 60 that we still use 4,000 years later. Our days have 60-minute hours and 60-second minutes, and our circles encompass 360 degrees. Chinese societies used an abacus with a system based on 10s, although it had no 0. An early form of decimal fractions came from the abacus. For example, 3/5 would be 6 out of 10 on an abacus. The Chinese lovingly named the numerator the sun and the denominator the mother. It wasn't until the 12th century that common fractions with the bar notation that we use today were invented. Even then, these fractions weren't widely used until the Renaissance period, only 500 years ago. Throughout history, every culture around the globe has created inventive ways to calculate. To solve a problem, say 12 times 15, early Russian peasants used a system of doubling and halving. When an odd number, halved, resulted in a fraction, they rounded down. Then they added the factors associated with the odd multipliers. Ancient Egyptians relied on a doubling procedure until they produced enough groups. Then they added these groups to find the answer. Across Europe and Asia during the Middle Ages, the abacus was the handheld calculator of its day, but only very few people knew how to use it, usually wealthy merchants and moneylenders. By simply moving beads that each had place value, an abacus was a highly efficient way to compute. Then, the great Arab mathematician Al-Khwarizmi introduced the Hindu-Arabic numerals 0 through 9 into North America and Europe and created new procedures for computation. These algorithms could be written onto paper. Over the centuries, learning the algorithms became the hallmark of an education as students were taught to compute long columns of figures, borrow and carry, and do long division efficiently and reliably. They could now keep records of these procedures and check results. Today, complex calculations are done with a handheld calculator. This means students need the ability to check the reasonableness of the answer and to have a rich repertoire of mental math strategies to do that. Most simpler computations, like 12 times 15, can be solved mentally using a variety of strategies. As we journey through the rich and vibrant history of mathematics, we can see how ideas and creations grew out of our very human need to solve the problems in our everyday lives. Through time, the mathematical explorations of men and women from around the globe have given us fascinating lenses that help us to mathematically view and make sense of our worlds.